Welcome to this lesson on gas stoichiometry. The question of the day, what do the coefficients in a balanced chemical equation actually represent? Stoichiometry is the relationship between the quantities of the reactants and the products before, during, and after chemical reactions. Today, specifically, we are going to take a look at how gases can play a role in stoichiometry. When working with gases, the coefficients in balanced chemical equations really represent moles, but because gases have a molar volume, it can also represent the number of liters. Remember, no matter the identity of a gas, 1 mole of that gas will have a volume of 22.4 liters. So the same way that we use a mole to group particles into bundles that we can actually work with, for gases, we can do the same thing with their volume. We're going to walk through one sample problem. Our question is, water is synthesized from its elements at standard temperature and pressure in a gas system. If 4.8 liters of hydrogen are used, how many liters of water will be generated? Steps here are going to be the same as any other stoichiometry problem, but how you carry out those steps are going to be a little bit different. So the first thing we need to do is determine and balance the equation. We started with a word equation, and we will now turn that into a real chemical equation. Water synthesized from its elements would be hydrogen and oxygen, both diatomics, forming water vapor. And then we'd have to balance the equation by putting a 2 in front of the hydrogen and a 2 in front of the water vapor. The next thing we need to do is change the given to moles. Because this is a gas at STP, we are going to use the ideal gas law and solve for N, number of moles. So we know that we would be at 1 atmosphere of pressure and 273 Kelvin from the fact that this equation, the whole reaction is happening at STP. The gas constant is a constant, it's the same all the time, and the 4.8 liters was given to us in the question. We're going to use algebra skills to solve for N, number of moles. This gives us 0.214 moles of hydrogen. Remember, this hydrogen is diatomic. Step 3, we are going to compare the substances that we know about and the substance that we have a question about using a mole ratio. The mole ratio comes from the balanced chemical equation. So we are being asked about water, and the information that we have is about hydrogen. So using those two pieces of information, we are going to set up a mole ratio. According to the chemical equation, for every 2 moles of hydrogen used, we can generate 2 moles of water. In our case, we are working with just 0.214 moles of hydrogen, and then X is going to be the number of moles of water. Because this is a 2-to-2 or really a 1-to-1 ratio, you didn't really have to set this one up. Those of us who are pretty math-brained know this. Some of us have to set it up in order to see it, but regardless, you would cross-multiply and solve for X in this case. Whether you actually solved for X or you just math-brained it, you wind up with 0.214 moles of water vapor. The last step is to convert your final answer back to whatever the question asked you for. So we can be asked about grams, which I will link the mass stoichiometry video in the description. So if you need a refresher on that, you can head there. That would be a QMT chart. We can find the number of moles, which would mean that we're already done. We can find the number of liters, which in that case, we would use the ideal gas law and solve for V, liters. And we could also do this for molecules. So it's very important to be mindful of what specifically you're being asked for. In this case, again, we're being asked for liters, so we're going to fill in the ideal gas law, but solve for V. The entire equation or reaction is happening at STP, so our pressure is 1 atmosphere, the temperature is 273 Kelvin. In this case, we're solving for volume. This is the number of moles of water vapor that we just solved for. And then this is the gas constant. Solving for all of that together, our volume is equal to 4.794 liters of water. Every stoichiometry problem will follow these same 4 steps, but again, how you carry out those steps is going to be a little bit different. When you are working with gases, you will use the ideal gas law to solve for both moles and volume. It's also important to remember that the ideal gas law has very specific units of atmospheres, liters, moles, and kelvins. So if your units are not in those 4 acceptable units, you will have to convert any measurements or values into those acceptable measurement units in order to put them into the ideal gas law. that is all I have for you on gas stoichiometry. Again, if you need help with mass stoichiometry, that link to the video will be in the description. Please subscribe so you don't miss the next lesson. Leave any questions you have in the comment section below the video, and I will see you in the next one. Bye.